Hello, math students. Welcome back to our module called Linear Equations. This is lesson 4, and it is called Solving a Linear Equation. So now we are pretty comfortable with what a linear equation is. Remember, it is an expression that is equal to another expression. The left side of the equation is equal to the right side of the equation. Our goal for today we will practice solving equations with rational coefficients. Remember, coefficient is the number that sits next to the variable, and rational means that it could be a whole number, it could be a fraction, it could be a decimal. So that's what we'll be working with today. The question that I want you to keep in mind is, what must every equation remain in order for it to be valid? Okay, so interesting. All right, so the first thing that I want to do when we get started is, a lot of times in the past, what you have been able to do is you have been able to look at an equation and you use logic to figure out what the variable represents. And so a lot of times when we're using logic, we aren't really using math at all. We're just using what we know about number sense, and we're balancing the equation in our head on both sides so that we can find the value for that variable. So for example, if you look at this one right here, we can use that process very easily because it says 4 times what number plus 1 equals 13. Well, I know automatically that 4 times 3 is 12 plus 1 is 13. That was very easy. The reason I know that is because I know my math facts, and I know that if I'm trying to get anywhere close to 13, I know that 4 times 3 is 12. Then you add 1 to it and you get 13. So that one, no math was involved. I just knew my math facts and I used logic. All right, so now we also have one that is a little bit more complicated looking, but I think we could probably figure it out if we really paid attention to what we're doing. So on this one, it says that I have 4x minus 9, and that happens 3 times, and then I have to add 10. And on this side, I have 15x plus 2 plus 7x, so I know that I have to do some combining of like terms. So if I figure this one out, this one says 12x minus 27 plus 10. So if I have minus 27 plus 10, then I really have minus 17. So now on this side, I have 12x minus 17, and on this side, I have 15x plus 7x is really 22x plus 2. So as you can see, it gets a little bit more complicated, and we do have to write things down because we have to keep them balanced in our mind. And so if I write down what we just came up with, this one is 12x minus 27 plus 10. So what it really is 12x minus 17, right, is equal to, and then I'm going to combine these two, which is 22x plus 2. And now I have to try to figure out a number that would make these equal to each other. So it would be 22 times something plus 2 is supposed to equal 12 times something minus 17. So it is solvable, but this is where you would start maybe plugging things in to try to figure out getting close to it. And so it takes a little bit more than just having math in your head to solve it. Some of you may be able to look at that and automatically know x equals something, okay? However, it takes a little bit more work. Sometimes it's not even that easy at all because we still don't know what the value of x is in here, and there's lots of different capabilities. So rather than sitting here going, let's try 2, let's try 8, let's try 9, let's try 4, let's try 3, okay, there is a better way of doing this. And one of the ways that I want to keep in mind is using your build and undo chart. And we haven't talked about this for a very long time, but I know that by now in this course you guys have gotten very accustomed to using the build and undo chart, and it's a very helpful tool. So solving for a variable requires a lot of steps. Some of them are mental, some of them are not. Okay, so try this one. 4 plus 1 equals 7 minus 2. Is that true? The answer very quickly inside our head is yes, because 4 plus 1 is 5, and 7 minus 2 is 5. So we know they're equal. Boom, done. That one was easy. This one is easy compared to this one that we still haven't solved. This one is easy, and this one is easy because they're about the same thing. All right, so now what I would like you to do is I would like you to remember the build and undo chart, and if you need it, then let's figure it out. So it says solve the linear equation. This is considered a linear equation because my exponents on my variables are 1. So now what I have is 2x minus 3 is equal to 4x. Well, in order to solve for the variable, the very first thing that you have to do is you have to get the variables all on the same side. Right now, we have a variable on the left-hand side of the equation, and we have a variable on the right-hand side of the equation. So the very first step, whenever you start to solve for a linear equation, is you've got to get the variables all on the same side. So step number 1 is get variables all on the same side. That's the very first step, okay? So in order to do that, we have to create 0 pairs because you're crossing an equal sign. You can't just move them. You actually have to do the opposite operation so that you can get them all on one side. Because if I just take this one off and put it over here, I can't really do that. And the reason why I can't do it is because right now it's connected to this constant. So we have to unhitch the connection between the constant and the term with the variable and the coefficient. So we have to unhook it. So in order to unhook it, what we need to do is the opposite operation. So right now, this is a positive 2x subtracting 3. So in order to unhook it, we can do it 2 ways. We can unhook the negative 3, because remember, subtraction is the same as adding the opposite, so this is really a negative 3. So we could add 3 to both sides, which would create a 0 pair. But the problem with that is we'd still have 4x over here, and we'd still have 2x over here, so we really didn't do anything. So what we want to unhook is the variable. So since this is a positive 2x, to undo that, I am going to have to add the opposite. So I'm going to have to add 2 negative x's. So if I add 2 negative x's, what I'm going to do is it looks like this. Minus 2x from this side, and I'm going to minus 2x from this side, because the rule is what you do to one side of the equation, you have to do the exact same thing to the other side of the equation. So when I do this, I get 2x minus 2x creates a 0 pair. So that side is gone. What you do to one side, you have to do the other. 4x minus 2x is now 2x. So what we have left in our equation is this negative 3, because remember, subtraction is the same as adding the opposite. So this is really a negative 3. So now it says that negative 3 is equal to 2x. So now the next step that you all should remember by now is use your BU chart. Okay, so we're going to do a BU chart right here to help us. So our variable is x. What are we doing to x? We're multiplying it by 2. So to undo that, we have to divide by 2, because that's the opposite operation, and then we'll be left with x. So that's not difficult. I'm going to divide this side by 2, and I'm going to divide this side by 2. 2 divided by 2 is 1, which 1 times x gives me x. So x equals negative 3 halves. And that's your answer, negative 3 halves. So now we have the solution for x, and that's what we were looking for. Okay, so that's pretty simple, yeah? Not difficult at all. Okay, so now let's try the next one. It says step number 1, get the variables all on the same side. So I'm going to use a different color this time. All of my variables happen to be on the same side because I only have them on the left. So actually, for this problem, I just get to go with the BU chart right away. So my variable is x. What am I doing to x? I'm multiplying it by 3/5. And you remember, whenever you're working with fractions being your coefficient, if you multiply by the reciprocal, that's how you undo it. So I'm going to multiply by 5/3, and then I should be left with x. So watch this. This is pretty cool. So I'm going to multiply this side by 5/3. Oops, I forgot a step because I also forgot to deal with this guy. So we need to continue this. I apologize. So adding the opposite. So this is actually subtracting 21. So before I do this step, I need to add 21 to both sides. I apologize. I forgot. So I'm adding 21, adding 21. I apologize. I jumped a step. So this would be a 0 pair. So that guy's gone. And this is now 36 equals 3/5 x. Sorry, I apologize. So now let's go back over here. And now we can multiply by 5/3. And what you do to one side, you have to do to the other. So I'm going to multiply this by 5/3. 5 times 3 is 15. 3 times 5 is 15. 15 divided by 15 is 1. 1 times x equals x. And now I do the same thing over here. So 36 times 5 gives me 180. So now I have 180 divided by, so this is 180 divided by 3, and that gives me 60. So x equals 60. So we found the value of x. Now, I didn't show you in the last step, but I want to go ahead and put it up here. You need to go back and check to make sure that they work. So let's plug in 60 for the value of x, and you plug it into your original if you can read it. So the original on this one said 3/5 x minus 21 equals 15, right? So now x equals 60, so I'm going to do 3/5 times 60 over 1 minus 21 equals 15. Let's see if it works. So 3 times 60 is 180 divided by 5 minus 21 should give us an answer of 15. Well, 180 divided by 5 goes 3, 6, minus 21 equals 15. And 36 minus 21, 6 minus 1 is 5, 3 minus 2 is 1, and now you see that 15 equals 15, so it checks out. Okay? So now I have a couple more that I want you to practice. I would like you to practice this one using these 3 steps up here. Get the variables all on the same side, build and undo chart, and then go back and check. So you need to do this one right here that you see, okay? And that's it. So I didn't give you any other problems. So this is the last one that I want you to try to find the value of x using those steps. Okay, so go backing up for our goal. Today we will practice solving equations with rational coefficients, which is what we did. What must every equation remain in order for it to be valid? The answer to that question is that it must remain balanced. Left side has to equal right side. Left side has to equal right side. They have to remain balanced. Okay? That's all I have for you today. Talk to you soon. Bye.